the ancient AOO lineage, the enigmatic Iwo Eleru skull, and the 19% ghost ancestry of West Africa are tearing apart the Out of Africa theory. West Africa was totally ignored in the classic Out of Africa story, but now the real story of Africa has emerged through DNA, fossils, and the crumbling of outdated ideas. In place of a simplistic idea of Africa as a cradle that produced a pure, untainted modern human species, instead we find something much more complex, more diverse, and more beautiful than anything Out of Africa ever imagined. Popular science magazines and documentaries don't discuss this topic because it is too groundbreaking, too mind-boggling, and frankly too complex for their audiences to grasp. You are one of the few open-minded people to be able to learn about this topic without filter, without politics, and without institutional biases. When the Ice Age began to loosen its grip on Africa and the world warmed enough for forests to push back against the encroaching deserts, two human worlds, anciently separated and profoundly different, finally converged. It was around 14,000 years ago, a moment when rivers returned to the Sahel and green corridors reopened across the continent. From the east came expanding populations of Homo sapiens, slender-limbed hunter-gatherers whose ancestors had drifted through Africa for tens of thousands of years. Their migrations followed new waterways, fresh pastures, and the subtle allure of unoccupied land. But West Africa was not empty. Ahead of these explorers stood a population unlike any they had encountered before, a deeply rooted, robust, and remarkably ancient people whose genetic signature diverged from all others long before Homo sapiens had fully taken shape. These were the descendants of a lineage now recognized in genetic studies as the source of up to 19% of the ancestry in some West African groups, a ghost population so deeply divergent that its origins lie at least 350,000 years in the past. For much of the Middle and Late Pleistocene, they persisted in ecological refugia across the Nigeria-Cameroon region, preserving a genetic and morphological legacy older than that of Homo sapiens. Their Y chromosome lineage, known today as AOO, diverged earlier than any other paternal branch in humans, as much as 500,000 years ago. This date aligns almost perfectly with the minimum age of the ghost population, and the geographic overlap could not be a coincidence. And yet these people were not archaic in the way textbooks once imagined. They built shelters, crafted stone tools, buried their dead, and lived as fully modern humans. Only they belonged to a branch of our species that had been evolving in isolation for hundreds of thousands of years. The meeting between these two populations, one newly arrived from the east, after the last glacial maximum around 20,000 years ago, the other deeply rooted in West African refugia, produced one of the most remarkable episodes in human evolution. It created the blended ancestry of modern West Africans and left behind fossils and genetic signatures that tell the story of a continent far more diverse and interconnected than once believed. The study estimated that the interbreeding happened sometime before 124,000 years ago, but the 19% ancestry suggests it was recent, very recent. Most likely less than 15,000 years ago, and possibly as recently as 5,000 years ago, because archaic DNA tends to get rapidly filtered out of modern human genomes, as happened with Neanderthal and Denisovan DNA. To trace this story, one must travel back to a rock shelter in southwestern Nigeria, where in 1965 researchers uncovered a skull that would puzzle scientists for decades, the Iwo Eleru cranium. Dated to roughly 12,000 years ago, exactly when the interbreeding most likely occurred, the Iwo Eleru skull belongs chronologically to the very end of the Pleistocene, long after Homo sapiens had established themselves across Africa. But its anatomical features do not match the gracile, globular forms characteristic of Holocene humans. Instead, the skull is long and low, with a subtly archaic brow and unusually thick cranial bone. Its shape clusters not with recent African populations, but with Middle Pleistocene specimens like Omo II from Ethiopia. The Iwo Eleru skull should have looked modern, yet it did not. It bore the unmistakable traits of a lineage that had endured in isolation, its form shaped not by the last 12,000 years, but by the last 200,000, but it was also modern, a hybrid. The existence of such a skull so late in time forces a radical rethinking of African prehistory. It reveals that archaic-leaning human groups survived in West Africa until the Holocene, long after similar populations elsewhere had disappeared or been absorbed. But the skull alone might have been dismissed as an anomaly, were it not for the genetic discoveries that followed decades later. When researchers analysed Y chromosomes from villages in the Cameroon highlands, they encountered a lineage that seemed almost impossible: AOO, a paternal branch that diverged from all other human Y lineages far earlier than any known lineage. It was an archaic genetic fossil preserved in living people. The age of AOO is staggering. Depending on the mutation rate applied, it may trace back 350,000 years, placing its origin in a period before Homo sapiens had fully emerged. That such a lineage survived into the present means that the population carrying it must have endured as a coherent group, shielded from the full sweep of migrations that shaped most of the African continent. And the region where they survived, the Cameroon highlands, is precisely the type of landscape that can protect isolated populations, rugged, forested, ecologically resilient through repeated glacial cycles. This region lies less than 600 kilometers, 350 miles from Iwo Eleru, close enough that the presence of two independent lines of evidence, one skeletal, one genetic, cannot easily be dismissed as coincidence. Together, they reveal a West African refugium where a deeply divergent human lineage persisted long after other archaic groups had vanished. But the most dramatic evidence of this lineage comes not from bones or Y chromosomes, but from the autosomal genomes of modern West Africans, where computational models suggest that up to 19% of ancestry derives from an archaic population that split from other humans hundreds of thousands of years ago. This ghost population, as scientists call it, is not a speculative invention. Its imprint can only be explained by prolonged isolation, followed by a major wave of admixture. These genetic signatures cannot be derived from known Homo sapiens populations. They require a divergent source, one whose separation predates the emergence of modern human morphology. The fact that West Africans show the largest archaic contribution of any population on Earth, larger even than Denisovan ancestry in Oceania, demands a rethinking of how human diversity unfolded across Africa. The structured stem model of human evolution, now widely discussed among anthropologists, provides the conceptual framework for interpreting this evidence. Instead of a single cradle of humanity, Africa hosted multiple populations that diverged early and remained partially isolated for tens of thousands of years. These populations did not evolve in parallel toward modernity at the same pace. Some, such as the ancestors of East African early Homo sapiens, underwent morphological changes earlier. Others retained more robust forms. And still others, like the West African ghost lineage, appear to have developed a blend of archaic anatomy and modern behavior, evolving in isolation within ecological shelters. The Iwo Eleru skull fits this model perfectly. Its archaic traits reflect not a regression or anomaly, but the persistence of a long-separated branch of humans whose morphology followed a different trajectory than that of their African counterparts. The Cameroon highlands, where the AOO lineage survived, would have been home to related groups. For tens of thousands of years, these populations lived adjacent to other Homo sapiens groups without fully merging, preserving their distinctiveness through cultural boundaries, geography, and the sheer difficulty of travel across rugged terrain. This situation remained stable until the climate changed. During the last glacial maximum, Africa's climatic zones were compressed. The Sahara expanded dramatically, pushing populations southward, squeezing them into narrower belts of habitable land and cutting off contact between regions. But as the Ice Age ended, rainfall returned. Forests advanced, lakes refilled, and the ecological corridors connecting eastern, central and western Africa reopened. It was during this period of renewed mobility that early Holocene populations began moving westward. These explorers, carrying the genetic legacy of Eastern African sapiens, entered a region where the long-isolated ghost population still lived. Their meeting was not unlike the encounter between modern humans and Neanderthals in Europe, except that in Africa it occurred in the open rather than in caves, and more recently than the deep ice ages. The two populations interbred extensively. The ghost lineage contributed morphological traits that survived into individuals like the Iwo Eleru skeleton, and genetic traits that remain today in the autosomes of several West African groups. In some models, this archaic population contributed nearly a fifth of the ancestry of certain peoples. Such a degree of admixture implies sustained, enduring contact, not a brief or isolated event. The result of this encounter was the formation of a new population, blending two deep histories, the incoming early Holocene groups and the long-rooted ancient lineage of the Nigeria-Cameroon refugium. Their union shaped the genetic landscape of West Africa as we know it today. Later expansions, such as those associated with early agriculture and the spread of Niger-Congo languages, further transformed the region, but the ancient core remained. In the DNA of modern West Africans, the echoes of this deep meeting still resonate. Perhaps the most compelling aspect of this story is that it mirrors a global pattern. In Papua New Guinea, isolated highland populations preserved high levels of Denisovan ancestry, remnants of a deep and ancient encounter. Geography protected that signal. The same appears to have happened in the Cameroon highlands, where the rugged landscape helped preserve not only the oldest Y chromosome lineage in the world, but also the genetic signature of Africa's last archaic people. The Iwo Eleru skull provides the physical embodiment of this legacy. It stands as a reminder that the past is not erased simply because new populations arrive. Instead, old and new worlds merge, forming the complex patterns that define humanity today. The fact that a skull so archaic in form existed only 12,000 years ago challenges the simplifying assumptions that once dominated paleoanthropology. It shows that Africa's human past was not a neatly ordered sequence, but a braided river of intersecting lineages. In this light, the survival of the AOO lineage becomes not a curiosity, but a testament to resilience. Its carriers today may not look different from their neighbours, but in their paternal line they carry a story that stretches back nearly 500,000 years, a story of survival through climatic upheaval, geological isolation, and eventually the merging of two human worlds. This story is shared in another form by the 19% ghost ancestry that shaped modern West African genomes. Together, these genetic markers reveal that the last archaic humans did not vanish early, but lived in the forests and highlands of West Africa until the dawn of recorded history. The meeting of these populations, the newcomers travelling west with the warming climate, and the ancient people rooted for millennia in the Nigeria-Cameroon corridor, created the mosaic that defines West Africa today. It was not a meeting of species or a confrontation between modern and archaic humans in the old-fashioned sense. It was the merging of two chapters of the same book, two long-separated branches of a single complex family tree. In their union, the deep past met the emerging future, and a new human population was born, one that still carries the traces of that ancient encounter in every cell. This is the beautiful story of AOO, of Iwo Eleru, and of the 19% ghost ancestry that has reshaped our understanding of human evolution. It is the story of how West Africa became not an evolutionary afterthought, but a living archive of the continent's deepest history, where two ancient worlds met at the end of the Ice Age, and for the first time in thousands of years, became one. Thanks for watching.